Welcome back, everybody. Today we're talking about perpendicular bisectors. Now, perpendicular bisector is exactly what it sounds like it is. We're talking about a line that's going to be perpendicular to another line segment. Perpendicular meaning it intersects at a 90-degree angle, and it's going to bisect that line segment. Bisect means it cuts that in half into two congruent pieces. So when we look at this, we notice that we have a line that is perpendicular. We notice the 90-degree angle is to our line segment. And we also notice that our line segment was cut into two equal pieces. These little marks right here tell us that these pieces are congruent. So we have line PQ as a perpendicular bisector of AB. Now, there's a theorem based off of that information, and that theorem says that if a point lies on a perpendicular bisector, then that point is equidistant to the endpoints of that line segment. So we have a point that's on the perpendicular bisector. That means that the distance from A to P is the same distance as it is from B to P. So I'm going to quickly just draw that in so you guys can see that. That distance, in green, is going to be the same distance over here. AP is congruent to BP. That's what this theorem says. Again, I'll show you real quick. Looking at point Q. Point Q is on a perpendicular bisector. We know it's perpendicular and we know our segment's been bisected. That means then that AQ is going to be congruent to BQ. So that's the perpendicular bisector theorem. It also has a converse. Converse just means that we can go backwards with this theorem and it will still give us results that we're looking for. So if we think about this backwards, what it's saying is that if a point happens to be equally distant to the endpoints of some line segment, then it would have to be on a perpendicular bisector. So let's take a look. Here's AL. It's the same distance as LB. We know that it's the same distance. Okay? That means that no matter what, if L happens to be equally distant, that would mean that it's going to land on top of a perpendicular bisector. That would give us the fact that this piece of line would have to be congruent to this piece of this line segment. And it also tells us that the intersection right here is perpendicular, which gives us 90-degree angles all around. So that's the converse. That's going to be useful when we start looking at some of these problems. So one example, it says, is line BD a perpendicular bisector of AC? Well, let's take a look. Here's BD, the line. We notice that it's perpendicular. We're not quite sure if it's bisecting AC though. But what the theorem told us, or the converse told us, is that if B is the same distance away from A as B is to C, then this would be a perpendicular bisector. But look, the distance from B to A is 8, where the distance from B to C is 13. So they're not congruent to each other. That means B is not on a perpendicular bisector. So the answer for this question would be no, because AB is not congruent to BC. They would have to be in order for it to be a perpendicular bisector. Let's check out this other example. Whoa, I'm looking at the picture and I'm looking right away. It doesn't look like it's perpendicular. That's not a 90-degree angle. And these two sides, look at how long this one is compared to that. right? But the trick to this is that we don't always have perfectly drawn pictures. Our pictures are not necessarily drawn to scale. What we want to look at is information that's given to us. Right now, I notice that I have QR is the same distance as RS according to the information given to me in my picture. So right now, this point is equally distant away from each endpoint of this line segment. That forces this to be a 90-degree angle right here, and it forces these to be congruent, which, look at that, it tells us that they're congruent. So we've used the converse in order to get the fact that this, in fact, is a perpendicular bisector. Okay, let's try some other types of problems. These problems are asking us to solve for x. Now, if you have a good idea of how these work, you might be able to try this on your own. So if you want to pause the video, give it a shot, we'll come right back and check out what the answer is. So this is how it works. We notice that we have a line that is perpendicular and bisecting a line segment. So right away, we know that the perpendicular bisector theorem starts to come in effect. That means that this line segment, it has to be congruent to this line segment because this point lies on the perpendicular bisector. That's useful to us because we can set up our equation 13x plus 8 being equal to 6x plus 50. Alright, let's move some stuff around. I'm going to subtract 6x from both sides. I'm also going to subtract 8 from both sides. That's going to clear out my 8 and my 6x. This leaves me with 7x on one side and 42 on the other. A little bit of division. Dividing by 7 will give us x equaling 6. Okay, and if we wanted to real quick check, we could plug that 6 in. 13 times 6 is 78, plus 8 is 96. We can check over here too. I'm sorry, it's 86. Over here we can check 6 times 6 is 36, plus 50 is 86. So we notice that they both have the same length of 86. Okay, so it works. Let's check this out too. Again, another example. If you want to pause and try it again, take a second and go for it. So here's what's happening. We have a point right here. It happens to be equally distant away. We know that because of these marks. That forces this to be a 90-degree angle, and it forces these two pieces to be congruent to each other. So I'm going to take a second to make sure that I mark that. Here we go. That's my perpendicular. And I'm going to mark that these two pieces are congruent to each other. That's useful again because we can set up this equation. Alright, let's do a little bit of algebra. Well, to get this x away from here, I'm going to add 2x to both sides this time. And I want to move my constants away, so I'm going to subtract 13 from both sides. That clears out that stuff. Leaves me with 11x equaling 77. And quick division, dividing by 11 on both sides gives me x equals 7. And again, we can quickly check this to make sure. 9 times 7 is 63, plus 13 is 76. Alright. Negative 2 times 7 is negative 14, plus 90 also gives me 76. So we got 76 for both of these. They're congruent. Everything worked out fine. That's the perpendicular bisector theorem. Pretty easy to use. It'll show up a couple times throughout this year, so let's not forget it.